We thought we knew this system. 7 planets. Discovered in 2017. Studied more than any other star system in history. Hundreds of research papers, thousands of hours of telescope time. JWST has dedicated over 8% of its entire observing schedule to staring at one single star. We thought we had the full picture. Then JWST found a signal that nobody expected. A faint dip in the light. A transit. The telltale shadow of something passing in front of the star. But it didn't match any of the 7 known planets. Something else is out there. And if it's confirmed, it will not only rewrite everything we know about TRAPPIST-1, it will be the smallest planet ever discovered, anywhere in the universe. Welcome to ExoFiles. If you've followed exoplanet science at all, you know TRAPPIST-1. It is the crown jewel of the search for life beyond Earth. A tiny red dwarf star sitting just 40 light-years from us, practically next door in cosmic terms, surrounded by 7 rocky, Earth-sized planets, 3 of which sit squarely in the habitable zone. It is the system we have bet the most on. The system JWST was partly built to investigate, and now, buried in the latest JWST data, there is a signal. A candidate 8th planet, designated TRAPPIST-1I. In this video, I'm going to walk you through what the TRAPPIST-1 system actually is and what this new signal shows. Why confirming it would be one of the most significant discoveries in planetary science, and what all of this means for the search for life. Which, by the way, is happening right now, as JWST stares at it this week. Let's get into it. To understand why a possible 8th planet is such a big deal, you need to appreciate what makes TRAPPIST-1 so extraordinary. The star itself is tiny, an ultra-cool red dwarf, the smallest category of star that exists. TRAPPIST-1 is only about 12% the size of our Sun. It is barely larger than Jupiter. If you swapped our Sun for TRAPPIST-1, it would look like a dim orange ember instead of a blazing torch. Packed into an orbit smaller than Mercury's path around our Sun, 7 rocky planets. All of them roughly Earth-sized. 3 of those planets, designated E, F, and G, sit in the habitable zone. The region where surface temperatures could allow liquid water. That last point is what drives the scientific obsession. 3 potentially habitable, Earth-sized rocky worlds, all in the same system. Because the 7 planets are so closely packed, they exert gravitational influences on each other that cause tiny, measurable variations. Scientists call this transit timing variations, or TTVs, and those variations encode information about the masses of the planets. It's those transit timing variations that first hinted something might be lurking further out. Measurements of TRAPPIST-1H showed subtle irregularities. The data seemed to be whispering that there was another gravitational source further out, pulling on the system. And then JWST found it. When a planet orbits its star, occasionally it passes directly between us and that star. It blocks a tiny fraction of the star's light. That is called a transit, and it is one of the primary ways we find exoplanets. The amount of dimming tells you the planet's size. In 2025, as JWST was accumulating transit observations, researchers noticed a signal that didn't belong to any of the 7 known planets. The candidate designation, TRAPPIST-1I. Here is what the preliminary data suggests. It would orbit further out than all 7 confirmed planets. Its orbital period is estimated to be longer, placing it in a colder, dimmer region of the system, and its radius would be 20% that of Earth. About the size of Neptune's moon Triton. If that radius holds up, TRAPPIST-1I would be the smallest planet ever confirmed. Now, and this is important, the detection is tentative. Science is appropriately cautious. But the TTV evidence independently predicted that something should be out there in roughly the location where this signal appeared. JWST has now mapped the climates of 2 of the inner planets, TRAPPIST-1b and TRAPPIST-1c. The results were sobering. The temperature difference exceeds 500 degrees Celsius. That enormous swing tells us there is almost certainly no atmosphere on either world. Then there is TRAPPIST-1e, the planet in the habitable zone that scientists have considered the most promising candidate for life. The data is not yet decisive, so the scoreboard right now reads 2 dead rocks confirmed, 1 ambiguous planet still under investigation. Now add a possible 8th planet. TRAPPIST-1I, if confirmed, would be the outermost world. It matters because it makes TRAPPIST-1 tied for the most planets of any known exoplanetary system. The gravitational architecture shapes habitability. Understanding TRAPPIST-1I means better understanding why the inner planets are the way they are. How does this get resolved? The process requires more transits. JWST needs to observe the signal multiple times. The challenge is telescope time. JWST is in extraordinary demand. The confirmation of TRAPPIST-1I is not just about one tiny world. It is about understanding the full picture of the most important exoplanetary system humanity has ever found. 1. TRAPPIST-1 is the most studied exoplanetary system. 2. Hidden in JWST data is a faint signal consistent with an eighth planet. 3. Confirmation is not yet achieved, but the corroboration gives it weight. 4. The system just got more complex and interesting. If this is the kind of content you came here for, real science, then Exophiles is where you belong. Subscribe so you don't miss it. See you in the next one.